Okay, so the question reads, to use Green's theorem to evaluate the integral of f dr, with f being the vector field given there, and c is the curve traced. It's a triangle from 0, 0, 3, 9, to 3, 9, and then 3, 0 to 0, 0. And the way we're going to do this is we will apply Green's theorem that says the integral of f dr on the curve C is equivalent to the double integral on the region D defined by the curve of dq over partial derivative of q with respect to x minus partial derivative of with respect to y multiplied by dA, where P and Q are the I and the j components of the vector field. So, so this will be my this here will be my P, and this here will be my Q underneath the letters. Okay, so then this becomes, let's actually find out what dq over dx is. Partial derivative of q with respect to x, we fix y, differentiate with respect to x, so we get 2y cosine x plus 2x, x squared becomes 2x, and dp over dy, we hold x fixed and we differentiate with respect to y, so this will be 2y cosine x. And of course, when I subtract the two, my integral becomes the double integral of 2x plus 2y cosine x minus 2y cosine x dA, and this goes away, and all I have left is 2x, and dA is just dy dx, double integral. Now let's go ahead and draw the region represented by this question. So the region here is, so we start, the question says start with 0, 0, go to 3, 9. So let's just say that this is 3, 9. And then go back from 0, 0 to 3, 9. So that's there. And then go to 3, 0. So 3, 0 will be straight down because this is 3. And then, so I'm going this way, then down, then back to 0, 0. So clearly I'm going clockwise around this curve. So then Green's theorem tells me that in order to get the positive orientation of this, because the general one, the theorem says that you have to go counterclockwise or in the positive orientation, and since this is clockwise, this gets you the negative orientation. So we are supposed to do minus C1, and because of this, we're going to have to multiply here by minus sign in order to get the right orientation. Now, and the way we will integrate this is we will find the equation of this line here. So this is a slope of 9 over 3, which is 3 goes through the origin, so the y-intercept is 0, so this is just 3x. So now we could say that this is a type 2 integral, 2x dy dx, with my y going from 0 to 3x and my x going from 0 to 3, and there's a minus sign here. And so now this is a fairly straightforward integral. I integrate with respect to y first, and when we would get 2xy from 0 to 3x, we go back and integrate with respect to dx, minus sign. And if we evaluate this for y equals 3x, we would get 6x squared. If we evaluate this with respect to 0, we get 0, so we don't have to write this down. And this is dx from 0 to 3. There's a minus sign here. So if I were to continue this here, we get 3x or 2x cubed from 0 to 3, and there's a minus sign. We evaluate at 3, we get 3 cubed is 27 times 2 is minus 54, and the other one gets me 0, so the final answer is minus 54. You could see how using Green's theorem to evaluate this integral, especially when we know what the area is, or bounds on the area, is a fairly straightforward process. This concludes this question. Please don't forget to rate and subscribe. Thanks.